Welcome to the Crazy Hat Chemist. So here we go. Today is Stoichiometry and Dimensional Analysis Unit, and today we're talking about 8.5. So Stoichiometry with balanced equations, the fifth video in balanced equations using stoichiometry. So here we go. Bam! So our problem here is the following. 0.950 grams of Nicholas nitrate. Solution is added to a solution of sodium hydroxide. How many molecules of nitrate product are formed? So the first thing we got is our flow chart all the time. We're going to have that all the time handy with us. Then what we need to do is we need to come up with a formula for Nicholas nitrate. Nicholas is a 2+ charge and nitrate is a polyatomic ion. Okay, then we need to come up with a formula for sodium hydroxide. Sodium is a group 1 and hydroxide is a polyatomic ion. So Nicholas nitrate is right here. That's the Nicholas, that's the 2+, that's a 2+ on the Nicholas, and the nitrate is a 1-. I'm going to take the absolute value of those two numbers, flip them, bring them down. I'm going to get Ni parentheses NO3 with a 2 on the outside. And then I'm going to have the sodium hydroxide, a 1+ charge, a 1- charge, absolute value of those two numbers, flip them, bring them down. They're 1s, I reduce them, I don't even have to reduce them, and I get rid of the 1s. So that's really nice. So now you're going to write out what it says solutions are. So they're states of matter that you're going to write down. So it says they're both a solution, but you should actually already know this, and that is nitrates are soluble no matter what. There are no exceptions. Same with sodium. So the sodium and the sodium hydroxide, those are also aqueous solutions. Okay? Now what you're going to do is try to figure out what type of reaction is this. Okay? So think about that, write that down. Bam, it is a double displacement. That is correct. Okay? Now what I want you to do, now you're going to think about knowing that it's a double displacement reaction and knowing that you have the Nicholas nitrate and the sodium hydroxide in their ionic state. Do crisscross applesauce, okay, and then come up with the products, include their states of matters, and then balance it. And then, after you're done with that, then restart the video. So you're going to pause here in just a second. So I want you to pause the video, write the products, balance it, include their states of matter, and then you're going to unpause the video. So here we go. Unpause. Bam! Okay, this is the balanced equation. The Nicholas hydroxide, you're going to have the 2+ on the Nicholas, and the hydroxide is a 1-. You're going to flip those numbers, bring them down. That's how you get the NiOH parentheses and a 2, and it is a solid because hydroxides are insoluble precipitates except for group 1 and ammonium ion. Okay, and then the other product is sodium nitrate. Sodium is a group 1, and then nitrate is a 1-. You take the absolute value of those, flip them, bring them down, and then you got aqueous, because all sodiums are aqueous, all nitrates are aqueous, so it doesn't matter which one you look at. I've got some 2 stoichiometric coefficients there for balancing, and then some 1s, and we got a really good balancing. So now we're going to reread that question again, and we have 0.950 grams of Nicholas nitrate. So we are going to start off with that Nicholas nitrate. And what do we want to go to? How many molecules of nitrate product? So I'm going to go for the nitrate product. Here is the nitrate product. So I'm going to go from the Nicholas nitrate to the nitrate product. You should see on the Nicholas nitrate, there's a stoichiometric coefficient of a 1, and the sodium nitrate on the product side has a stoichiometric coefficient of a 2. We're going to be using that in just a second. Now look at your flow chart, and you're starting off with grams. Grams of Nicholas nitrate. You're going to go to moles using the molar mass of Nicholas nitrate. Then from moles of Nicholas nitrate, you're going to go to moles of sodium nitrate. That's the nitrate product. Then from moles of sodium nitrate, then you're going to go to molecules. And that's using Avogadro's number. So what I want you to do is I want you to pause the video, write out that monorail. Remember, every single step includes a number, units, and a formula. You're going to look at significant figures in each one of the steps. Write down the significant figures that you have. Use your calculator to get an unrounded answer. Write that down. Then using your significant figures, then round your answer correctly and make sure that your answer has a number, units, and formula. That's fun in reverse. Here we go. Unpause that video. Bam! So we are using this blue rectangular dotted box here as our mole ratio. That's how we can change from one set of units to another set of, one set of formula to another formula. Okay, and it always has to be in mole ratio. You can't use this mole ratio. It's no gram ratio, no molecule ratio, no liter ratio. It's only a mole ratio. Okay, so that first here, we got our molar mass of Nicholas nitrate is canceling out. That has 2 decimal places. Then the moles of the Nicholas nitrate cancel out, and then the moles of the sodium nitrate cancel out. Okay, then we're going to look at significant figures. My beginning number, the 0.950, that leading 0 is insignificant, but that trailing 0 does count because there's a decimal in the number. That's why that has 3 significant figures. Then there's infinite in front of the 1 in the mole. There's infinite for that 2, and then 4 for the Avogadro's number. Then 5 significant figures for the Nicholas nitrate, and infinite here for that 1, and infinite for that 1. So the fewest number of significant figures I have on this problem is 3. So I'm going to put all these numbers in my calculator. This is my unrounded number from my calculator. I'm going to round this with 3 significant figures. I'm looking at that 2. That 2 is less than 5, so I'm going to truncate the number, and then there's my number. Correctly rounded, 6.26 times 10 to the 21 molecules of NaNO3, that's sodium nitrate. Every single step, and with the final answer, I have a number, units, and a formula. Okay, make sure that you got all that. All right, there we go. We've got a happy birthday hat on today with lots of candles. And I'm older than all these candles are. So that was stoichiometry with balanced equations. There were 5 of those in that. Okay, we're still going to continue on. Our next video is going to be on percent calculations. Okay, so hold on to that because we've got more coming. See you then. Bye.